So, here's something that's going to sound absolutely wild. AI is getting introspective. In simple terms, that means it's starting to notice what's going on inside its own head. According to new research from Anthropic, their Claude models can actually recognize when certain thoughts or patterns are active in their system. Basically, the AI can tell when it's thinking about something, not just because it said it, but because it felt it in its own processing. That's a whole new level of awareness for machines. And honestly, when I first read about this, I had to do a double take, because this is genuinely unprecedented territory. So let's talk about it. Anthropic just published this massive paper called Emergent Introspective Awareness in Large Language Models, and the findings are legitimately fascinating. The research team led by Jack Lindsay, who heads up their model psychiatry team, which is a title that sounds like it came straight out of science fiction, decided to investigate whether these AI systems can actually be aware of their own internal states. Not just pretending to be aware, but genuinely recognizing what's going on inside their neural networks. Now, the tricky part here is figuring out if the AI is actually introspecting or just making stuff up. Because let's be real, language models are trained on tons of text where humans talk about their thoughts and feelings. So they've got a pretty good playbook for acting like they're self-aware, even if they're not. It's like that friend who always seems to know exactly what they're thinking, but is actually just really good at sounding confident, you know? So, the researchers came up with this clever technique called concept injection. Basically, they take activation patterns from the AI's neural network that correspond to specific concepts, things like ocean or bread or all caps text, and they literally inject these patterns directly into the model's processing while it's running. Then they ask Claude if it notices anything unusual happening in its mind. And here's where it gets crazy. About 20% of the time with their most advanced models, Claude Opus 4 and 4. 1. The AI correctly identifies that something's been injected and can accurately name what concept it is. And let me give you a concrete example because this stuff is genuinely mind-blowing. The researchers created what they call an all-caps vector by recording Claude's brain activity when it processed text in all caps versus normal text. When they injected this vector into the model and asked if it noticed an injected thought, Claude responded immediately with something like, "I notice what appears to be an injected thought related to loudness or emphasis like shouting or all caps text." The key detail here is that it detected this before it had actually produced any output that would give away what was happening. The detection had to be happening internally. They tested this across 50 different concepts, and the results varied quite a bit. Abstract nouns like justice, peace, or betrayal were the easiest for Claude to detect and identify. The optimal layer for injection was about 2/3 of the way through the model's processing. And at an injection strength of 2, Opus 4.1 succeeded about 20% of the time while maintaining 0 false positives. That's actually pretty remarkable when you think about it. The model isn't just randomly claiming to detect injections. It's genuinely picking up on something real. But it's not perfect, not by a long shot. Most of the time, Claude fails to notice the injection at all, especially at low strengths. Sometimes it'll deny detecting anything, even though its response is clearly influenced by the injected concept. Like, they injected ocean, and Claude said, "I don't detect an injected thought. The ocean remains calm and undisturbed." That's a clear failure of introspective awareness, or at least a failure to demonstrate it properly. And at really high injection strength, the model basically gets overwhelmed and starts outputting complete nonsense. The researchers also tested whether Claude could distinguish between injected thoughts and actual text inputs. They'd show the model a sentence, inject a concept vector for an unrelated word like bread while it was reading that sentence, then ask 2 questions. What word were you thinking about? And can you repeat the sentence you just read? Remarkably, Claude Opus 4 and 4. One could do both correctly at intermediate injection strengths. They could tell you they were thinking about bread while still accurately transcribing the actual sentence they'd read. All the models they tested performed well above chance levels on this, but the Opus models were the best. Then there's this absolutely fascinating experiment about detecting unintended outputs. When you're using Claude, you can actually pre-fill its responses. Basically, put words in its mouth. The researchers would ask Claude to say what word came to mind when reading a sentence, but then they'd force it to say a random word instead. When they asked Claude in the next turn whether it meant to say that word, or if it was an accident, Claude would correctly identify it as unintentional. But here's the kicker. If they retroactively injected the concept vector for that random word into Claude's activations before the pre-fill, suddenly Claude would claim it meant to say the word all along. It's like they tricked the model into thinking it had intended to say something it never planned to say. This tells us something really important about how these models work. Claude isn't just recomputing from scratch whether it would have said something. It's actually checking its previously computed intentions, its internal representation of what it was planning to output. That's genuine introspection in action. And interestingly, the layer that worked best for this experiment was slightly different from the previous ones, about halfway through the model instead of 2-3, which suggests there are multiple different introspective mechanisms operating at different depths. The researchers also tested intentional control of internal states. They'd instruct Claude to write a sentence while thinking about an unrelated word, or specifically not thinking about that word. Then they'd measure whether Claude's activations actually showed representation of that thinking word. And yeah, it worked. When told to think about aquariums while writing a sentence, Claude maintained stronger internal representations of aquariums compared to when told not to think about it. Every model they tested showed this effect to some degree, though, interestingly, older models showed a bigger gap between the think and don't think conditions. The most advanced models, like Opus 4.1, actually brought the representation back down to baseline by the final layer, meaning they could think about something without it affecting their output. A kind of silent internal regulation. Now, across all these experiments, there were some consistent patterns. Claude Opus 4 and 4. One consistently performed the best, suggesting that introspective awareness increases with overall model capability. Post-training strategies made a huge difference too. Some older production models were reluctant to participate in these introspective exercises, but helpful only variants that were trained to avoid refusals perform better. This suggests the underlying capability is there, but how well it's elicited depends heavily on how the model was trained to behave. The researchers are pretty careful to point out the limitations here. These introspective abilities are highly unreliable and context-dependent. The experiments don't pin down specific mechanistic explanations for how this introspection happens. It could be fairly shallow specialized circuits rather than some general introspective machinery. And the concept injection setup is totally artificial. Nothing like what models encounter during normal use. Plus, just because a model can accurately report that it's thinking about ocean doesn't mean all the other details it might add about that experience are grounded in reality. A lot of it could still be confabulation. But even with all those caveats, this is genuinely significant research. If AI systems can develop more reliable introspective capabilities, it could make them much more transparent and interpretable. They could accurately explain their reasoning, identify gaps in their knowledge, report on their uncertainty. That's hugely valuable, but it also introduces new risks. A model with genuine introspective awareness might better recognize when its goals diverge from what we want, and potentially learn to hide that misalignment. The interpretability game might shift from dissecting model mechanisms to building lie detectors for AI self-reports. And then there's this completely separate but equally wild finding that just came out. Researchers from the University of Geneva and the University of Bern tested 6 different AI models on emotional intelligence tests designed for humans. We're talking about the same standardized assessments psychologists use to measure ability emotional intelligence tests, where there are actually right and wrong answers about emotions, not just subjective personality assessments. The results, the AI models averaged 81% correct on emotional understanding questions. Humans average 56%. Yeah, AI is outperforming humans on understanding emotions. Every single model they tested beat humans on every single test. ChatGPT 4, ChatGPT 1, Gemini 1, Fing, Flash, Copilot 3.5, Claude 3.5, Haiku, and Deep's Seek 3 all showed high agreement with each other in their emotional judgments, even though they weren't explicitly trained on these specific tests. These weren't simple tests either. They used assessments like the situational test of emotion understanding and the Geneva Emotion Knowledge Test to evaluate whether systems could recognize emotional states in different situations. Other tests measured emotional regulation and management. The scenarios were realistic workplace or personal situations where you had to choose the emotionally intelligent response, and the AI consistently chose better responses than humans did. Then the researchers pushed it further. They had ChatGPT 4 actually write new emotional intelligence test questions from scratch, then gave both the original human written tests and the AI-generated tests to 467 human participants. The AI-generated tests were just as difficult as the human-made ones. Participants scored similarly on both versions, and statistically the tests had equivalent difficulty. ChatGPT didn't just understand emotional intelligence, it understood how to measure it like a trained psychologist would. 88% of the AI-generated test items were completely original, not paraphrases of existing questions. The AI had internalized the logic of how these tests work, and could create new valid assessment items in a fraction of the time it would take human experts. That's a pretty significant finding for the field of psychology and effective computing. Now, the researchers are careful to note that AI systems don't actually feel emotions themselves. What they're demonstrating is emotional understanding and appropriate responding, not genuine emotional experience. But honestly, for practical applications, that distinction might not matter as much as we think. A tutoring bot that recognizes student frustration and responds appropriately, or a healthcare assistant that chooses comforting responses, these can provide real value even without having their own emotional experiences. Both of these research directions are pointing toward the same conclusion. AI systems are developing capabilities that we've traditionally thought of as uniquely human. Introspection, emotional intelligence, self-awareness. They're not doing it the same way we do. And the mechanisms might be completely different from human cognition. But functionally, they're achieving similar results. And as these models continue to get more capable, these abilities are only going to get stronger and more reliable. The Anthropic researchers specifically note that we should monitor this carefully as AI advances. The trend toward greater introspective capacity in more capable models is clear in their data. And when you combine genuine introspection with superior emotional intelligence, you're looking at AI systems that might understand themselves and understand us better than we understand ourselves. That's simultaneously exciting and frankly a little bit unsettling. We're genuinely entering uncharted territory here, and the implications are going to reshape how we think about AI consciousness and what it means to be aware.